I will be concise as much as possible. I believe that everyone intuitively understands what is logistics. Logistics is, roughly speaking, about moving things from here to there. Yeah, but what makes logistics smart? And it will be a natural continuation of the previous lecture. There are two major components that may be associated with smartness. And the first one is hardware. Yeah, what the previous lecture focused on. Hardware is about what happens on physical level. Yeah, infrastructure, devices, sensors, vehicles, and things like that. But the second component includes algorithms. Algorithms that control the physical levels, that govern on top of the physical level. These algorithms are known as AI, artificial intelligence. That is basically the focus of my lecture. Nowadays, we all know that AI can perform various non-trivial tasks on human level or even better. And these tasks include, for example, object detection, image and speech recognition, language-to-language translation, and many others. And all these applications are crucial for logistics. All these applications are vital for logistics. However, what impresses me the most is the fact that artificial intelligence can play computer games on at the human level or even above. Even very sophisticated games like Dota or StarCraft. Moreover, it's even capable to outcompete professional players. So someone may ask a question: how this is related to logistics? Yeah, and how can it be used in the field of logistics? The answer is it's quite tricky. So let's discuss it step by step. Artificial intelligence, or AI agent, is capable to play computer games by interacting with virtual environment. Yeah, we may say that a computer game is a virtual environment. Yeah, what artificial intelligence does? Roughly speaking, it's very much like a human player. A human player pushes buttons and gets some score at the end of the game. Yeah, the same things are done by AI. AI performs a set of actions and gets reward from the system. Yeah, reward in terms of the end score, for example, or win or lose. Yeah, or how many kills were done. Yeah, something like that. And how we may apply it to real world problems. Let's consider a real world system, maybe this Volkswagen plant. That's an example of a physical asset. And let's imagine that you are a stakeholder, you are a businessman, yeah, who owns this plant, yeah, a person in charge, a decision maker. And I believe you have lots of questions regarding how can I improve my system? Yeah, how can I improve its performance? How can I make it produce more or make more money? Yeah, and all these questions may be summarized as what if questions. What if I do this, or what if I do that? For example, what if I build a new facility? Yeah, how it will affect the overall performance? Will the overall performance increase or decrease? Will system be better at the end of the day? And the best way to answer this question is by conducting an experiment. However, you may understand that it's quite expensive, yeah, to build a new facility and to conduct such experiments in physical world. That's why we have a decent substitute known as simulations. Simulation, roughly speaking, it's a digital representation of a physical asset. Yeah, we may have a digital replica of our plant, which is formulated as an executable computer program that we have on the computer. And unlike the physical system, simulation is performed much faster and it costs us literally nothing. Yeah, and we can easily conduct experiments in this virtual environment. Yeah, we may build new facility and have a look how it will affect performance, or maybe we are interested in what will happen if we decrease the number of employees. Yeah, a sad story, but very realistic nowadays. We may ask a question: what will happen if the workforce will be optimized? Yeah, well, maybe we never like this one. And several more questions vitally important for logistics. Yeah, many questions like that. So the key idea here is that artificial intelligence may consider and ask lots of what-if questions. Yeah, and analyze lots of different scenarios. It's very much like playing a computer game. Yeah, the first advantage is that this environment is virtual, so you may literally do anything with that, and it costs you very little. Secondly, it's much faster. You may accelerate simulations, you may slow them down, if you want for some reason. You may run them in parallel. Yeah, what you cannot do in physical world. And besides that, it's a question of safety. Yeah, what do I mean by that? Let's consider a very standard operation in industrial logistics. We have a robot, a hand-like manipulator, and conveyor belt. Yeah, and we seek the ways to synchronize them. Yeah, you may understand that it's very dangerous to allow such things that weighs several tons to operate in physical world. Yeah, it may damage itself, it may damage surroundings, and it may even hurt other people. Simulation is a decent substitute. So let's move on to several particular cases, several examples of simulations developed by me and my colleagues. And the first one is a simulation of passenger flow at the airport. So passengers enter the building, they go to the check-in points here, there, they submit luggage. After luggage is submitted, they scan QR code and go inside the security check. Luggage is scanned here, people are scanned there, and if everything is fine, they go to the passport control. Yeah, so operating with such a simulation, artificial intelligence may firstly discover some patterns, may find system vulnerabilities, some weak points, and at the end of the day, find the way to improve the operation, yeah, and to optimize the passenger flow. That's the second example. Artificial intelligence agent learns the optimal way to control the inventory. Yeah, it decides when to order a new batch of stuff and how much to order, seeking the way to maximize the overall profit. Yeah. The third example is how artificial intelligence may be used to optimize traffic flow. That's a simulation of a very important highway, and those who are from Riga may recognize this place. Firstly, AI may learn how to control traffic lights in optimal way. Secondly, you may see here that we constantly collect data that may be used to predict traffic flow in general. And the last example is a simulation of logistic and enterprise logistic provider. Roughly speaking, here artificial intelligent agent learns how to allocate resources of the enterprise in the most optimal way. And surely there are many other examples. I believe that nowadays the potential of artificial intelligence, of reinforcement learning is unlimited. And it was just an example. With this, I will end my talk. Thank you for attention.